welcome everyone. Welcome to our Data Vault on Snowflake webinar. Today you will learn about how giffgaff built its own Data Vault solution on Snowflake with the help of Infinite Lambda. Before we jump into the presentation, I would like to encourage everyone, please feel free to ask your question during the presentation or in the Q&A session. We will answer all these questions, and as usual, after the webinar, you will receive the recording with the questions and the answers as well. So let's start our talk today. First, let me give you some introduction. I'm Zoltan, and I'm an enthusiastic data consultant, architect, and devoted data modeler at Infinite Lambda. My primary domains are insurance, finance, telecommunication, education, and retail. And I live in the UK with my wife and my 3 wonderful children. Over to you, Dmitro.
Yeah, hi guys, I'm Dmitro, also based in London. For the last 5 years working at Snowflake and really passionate about helping organizations to become data-driven. I'm also in the Data Vault community and really excited about having the chat today. Over to you, Abby.
Hi everybody, I'm Abby Yates. I'm a senior data engineer at giffgaff. I've been working in the data space for too many years that I'd like to admit. Historically, kind of on the Microsoft BI platform, but in more recent years, I've moved over onto Snowflake and working on data solutions. So looking forward to sharing some of our experiences.
Thank you, Abby. So let's go forward and take a look at our agenda. Here's what we are going to cover today. I will kick things off with a quick introduction to Data Vault 2.0. Then Dmitro will take over and break down how Snowflake works with Data Vault. After that, Abby's got a real success story from giffgaff, and where we will see how Snowflake and Data Vault team up in a real world. So just a quick introduction. Who is Infinite Lambda? Infinite Lambda is a global consultancy company where we provide end-to-end solutions, data solutions, starting from strategy and business requirements through implementation and trainings. Plus, we are Snowflake Elite partners and DBT Platinum partners as well. So the first part in my introduction is Introduction to Data Vault 2.0. This is going to be a high-level introduction about the basics. And I will talk about why and when you want to use Data Vault, and how to decide if Data Vault is a good fit for your needs. So let's start talking about the Data Vault goals, 2.0 goals, why Data Vault was invented in the first place. And these are the main reasons why Data Vault was invented. And the idea behind the Data Vault was to do better data vault modeling than the traditional solutions with dimensional modeling, because legacy data warehouse solutions kind of struggled with the complexity. They were slow to adapt to business changes. And these changes often, even if you did this, caused unexpected issues due to technical challenges and dependency in the processes. So as you kept growing your legacy data warehouse solution with dimensional modeling, for example, the cost of changing processes and stuff and dimensional effects starts exponentially growing. So fixing those problems meant we had to reload parts of the data warehouse. Sometimes fixing these issues also were near impossible because we didn't have the necessary level of historical data. Furthermore, automatization and code generation were also a big challenge with dimensional modeling. So these are the main focus points where Data Vault was intended to help. So these are exactly the same points when you can expect to solve problems with Data Vault. So when you think about the right tool, right solution, this is what you should have in mind at the beginning. But as part of the introduction, I would like to give you the common official version definition of Data Vault 2.0. which I'm not going to read, but it's going to show you the common misconception when people associate data vault 2.0 with data vault modeling only, and this is not the case here. But if this data vault is not just modeling only, then what is data vault 2.0? So it's not just modeling. In fact, we say that data vault 2.0 is a set of rules, best practices to design and build an efficient data warehouse solution. And here are the three main pillars: the methodology, architecture, and modeling. The methodology is emphasizing following the agile principles and practices. Effectively, it means that we focus on iterative and incremental delivery, but it also provides efficient ways to handle change management stuff. The second pillar is architecture, and it's going to give you a scalable and adaptive system. And we talk about S3-layer data architecture. Each of these layers has their own well-defined purpose, and you are going to see this. It's going to be very well structured. This helps you with the scalability as well. The third part is the modeling. This is the most well-known part, which gives you simple components which are easy to understand, but still using these simple components, you can build very complex solutions. And here is the place where you can find hubs, links, and satellite entities. Then we get very well-defined blueprints here in the modeling section, how to design and implement these models, these entities. And these templates are provided. If you follow the rules, you will have a very resilient, flexible, and fully audited model and data in your data warehouse. And I also actually added one more point here, the technology, because data vault could be implemented by many different technologies, but these are not the same, and not on the same level. So it's very important that the technology actually support data vault processes, and Snowflake is the best in this regard. That's why we most of the time recommend use Snowflake together with data vault solution. You will hear more about this in detail from Dimitro later on. So we talked about the purpose of data vault 2.0, but where is the place of data vault in the architecture? Data vault is an enterprise data warehouse solution, so such a thing is responsible for data integration and core business transformations. Data vault in a way handles complexity by splitting the task here. We have a raw vault and a business vault. In the raw vault, we do not do any kind of business transformations. We integrate the source data by business core concepts, which are the hubs. But we also use data vault sometimes, which is an optional and scarcely modeled layer. And here in the business vault, we tend to use business logic. For example, handle duplication, redundancy, data quality issues, which actually not errors, but coming from the source system still hold some kind of value. We still use dimension modeling, as you can see in the data products part. And the dimension model star schemas are sitting on top of data vault. And sometimes we use white tables as well, or other products, feature store, experiment, or just direct APIs. And we talk about data products here, but for some users, actually data vault itself can be a product. As this is the same case in giffgaff as well. For example, when you have data scientists, they are very much capable of using data vault. Even data vault is even if data vault is not designed for direct queries. Let's go forward with the data vault modeling entity types. This might be familiar for some of you. And we talk here about data modeling. Think about hubs, links, and satellites. This is the core business concept, which we call hubs, such as customers and orders here. We get these information from the business analysis, business talking to the business with a collaborative way. These core concepts are connected with links. Again, information coming from the business. And the last step is we add descriptions, information to the satellite, and connect these to hubs and links. As you can see on the screen, for the customers, actually we have 3 satellites. These satellites hold the customer detailed information coming from 3 different systems. You can see the integration here. Still integrated to the same business concept, same hub. And these satellites are going to track all the changes in the most basic level. So the hubs are the core business concept, which are actually never going to change unless the business itself is changing. This is the basic data vault entity types and the relationships between these. But how can we think about the process of creating a data vault solution? And the first step is starting from the business again. I will talk about business first more than once because that's very important point when you start working with data vault. So we start in order to achieve, we start business successes, business value. We start always from the business. The first step is we understand what we need, what are the requirements from the business. We here actually create business conceptual models. You can think about ontologies and taxonomies. Basically, we have to understand how the business is working, and also this is very good option to get connected to the business. It's just going to be, data vault is never going to be just a technological exercise. The second step after the top down is the bottom up, when actually we want to understand the actual data we have in the data sources, in the databases and the tables. We use data profiling and other methods to analyze our sources. And the third step is fill the gap, we call it. This is the final step, when most of the times we find that there are differences between the business understanding and the actual data in the databases. And in this step, we apply business logic to get a consistent result. We kind of connect the dots here. We just mentioned before the duplication issues from multiple systems. That's just one use case for this one. If you follow these steps, you can make sure that the solution will be scalable and future-proof. Plus, we don't have to prove the business value since we started from the business requirements and processes. That's also very important, in my opinion. And it's we have to repeat it again and again. And about the basics, to summarize how data vault create actual value, we have to understand the business and the data in order to provide business value. That's, I think, it's very basic. We need to foster collaboration, and in order to understand business, we data modelers, architects, data engineers work together with the business subject matter experts. That's one of the way how it will deliver value. Because by doing this, we build trust and we foster collaboration. Since data vault components are loosely connected, it's easy to extend them. Data vault is actually very much forgiving when we make mistakes. That's another value here. We can change if we had a wrong idea. We create a new version for the model. We don't have to break existing processes. We just keep extending. We create a new version. That's how it also provide value. And another part is repeatable patterns and automatization, which is going to help you create faster and products. We don't have to reinvent the wheel here. We can rely on the best practices and templates, which is provided in the Data Vault 2.0 standard. So we will not have to make mistakes again. We do not have to do manual coding. We use the architecture and processes and automatize the code generation in a way that we get consistent result, less error from manual processing. And everything is possible because we have these very simple components like hubs and satellites, very nice processes and repeatable patterns. So just again, repeating, starting from the business requirements, so we know what we do actually and why. So as we saw, data will truly shine when you have complexity, many sources, the need for integration and auditability. But for large organizations, we have one more topic here connected to the data vault. And here's that my last slide at the beginning, that the message here is basically a data vault works in production teams, data mesh and domain-driven approach as well. So here what we have is data vault works in centralized and decentralized organization. So you can have different product teams and domain working independently in a data warehouse. Each of the domains have their private area and shared products as well. As you can see, the raw vault, business vault, and utilities here are shared. But also each product team, like a sales product team, can have their own custom utilities and experimenting area like laboratory. They have business vaults, probably, which is optional, but they can create this. And this could be private, and also they can share these ideas. And at the end of this process, they probably will create dimensions of facts, white tables, whatever they have. The important thing is that the integration is possible, mostly using business concept. Since you identify data owners, you will have your business area, you will be the subject matter expert, the owner of this area, and you will most likely be owning this concept with the hubs. Probably others will use your data vault entities or just dimensions of facts. The only important thing is that we have to not forget is that we have to agree on the technologies, the rules, and the product deliverables. So that's also going to help you a lot with collaboration and autonomous business vault delivery as well. So that was all about the basics of data vault. And over to you, Dmitro.
Amazing. Thank you, Zoltan. Really, really cool introduction. And Zoltan just made a couple of interesting claims that I'll try to support in the next 10 minutes about Snowflake being the best platform for data vault. And let's start with a little bit of an overview of what Snowflake is, right? So Snowflake is the data cloud. We define it as a global network that allows you and your colleagues to connect to all data, all services, and all applications that your organization need to strive in the business domain. We functionally divide it in two large components. One is the best-in-class data platform that allows you to practically work with a data problem of any scale, from very little to unlimited capacity of different kinds. And the other one is content and collaboration on the content. That we started this journey back in the day with, again, offering supported by a unique architecture, allowing you to connect to the data sets without the need to implement file-based or service-based integrations within the Snowflake ecosystem with zero latency. And we're now expanding it to connecting not only to the data feeds and data sources, data sets, but also to applications, containers, ML models, LLM models. And as you would notice on this slide, for us, warehousing, data lake, and other workloads are different workloads represented as a part of a single platform. Now, why it matters? First of all, when I joined Snowflake, by that time, I was working with pretty much everything under the sun, with starting from shared disk to MPPs to NoSQL to all the Hadoop possible implementation. And what really, really surprised me on the day one is the fact that Snowflake just works. It is delivered as a service where amount of automation, amount of things that taken care either by design and the architecture or completely automated as the Snowflake team as a service, is allowing you and your team to focus on what matters for your business. And all of us been following this dream to become more agile, to have smaller one-size-pizza team, if you like, to have more time and better understand the business domains that we are dealing with. That is one of the approaches. Plus, in general, I'm one of those who prefer to deliver business products rather than wrangle with tech. However, at the same time, it needs to be a solution that is scalable, that is future-proof, that is basically not a toy, right? Not something that looks nice, but not gonna scale as data appetite are gonna grow. So Snowflake is designed with extreme scalability, with unparalleled scalability for concurrency and data volumes in class. And of course, this connection between different audiences, different products, different experiences, different modeling and implementation methodologies, as we will discuss, is critical. Now, we are the platform that works, feels, performs pretty much the same across all three major clouds, which is really, really cool, because when your organization is truly global, you really want to make sure that whether it's business continuity, high availability setups, or just being able to connect to the services that different cloud providers provide without significant overhead and complexity, is something that Snowflake would help, making it Snowflake Data Cloud as a common denominator. And if it would be just available in those different regions and different clouds, that would probably create yet another data silos, the problems that we are starting to tackle from back in 2012. Instead, we're delivering the ability for you to collaborate, to share data across those pods, to create a cross-cloud governance from a centralized and simple to change perspective. So the first component I remember mentioned is the data platform, right? And architecturally, we've started with something completely different, right? We didn't bring any on-prem system to the cloud and make it faster. We really designed something that is truly leveraging the elasticity and scalability that only cloud could provide on a day one. At the middle, it's a four-layer architecture. In the middle, it's always going to be your data. In this representation, it's just a barrel and a file, but ultimately it's the model as you see fit in your landscape, right? We're going to talk about modeling in a few clicks, but whether it's structured, unstructured, or semi-structured data, you have home for this. And it's infinitely scalable, right? From small volumes to whatever matters. Then the second layer is this elastic multi-cluster compute, which helps you to separate not only storage and compute, which was a very common phrase in our perspective, but also what's important, compute from another compute. So regardless how many users are dealing with data, regardless how many processes are dealing with data, they never step on each other's toes. Your reports are never going slower, regardless how much data you're processing. And then surrounding it, the cloud services and SnowGrid is everything that makes it looks like a very simple to understand product, right? We started with SQL, ANSI SQL standard plus extension. So anybody who had experience with the generic database was able to go Snowflake 0 to hero in minimum amount of time. But also nowadays that includes other languages like Python, Java, Scala, as well as, again, simplifying a lot in the maintenance, a lot in the administration that previously was requiring to have a significant team dedicating their time to this. Now, the elastic multi-cluster compute is, to be honest, one of the significant reasons, and I'll try to connect this to the data vault, why people really, really love Snowflake for data vault, right? You usually start small. Once you understand the benefit, the true benefit of this agility and incremental delivery, as Zoltan mentioned, sprint by sprint, bringing more models, more artifacts into the execution, you would really see how important it is to have the ability to currently scale out for processing more of those hubs, links, and satellites without, again, over-engineering the scalability part. Or when you have more data to process, or more complex reports and joins and aggregations to perform, how easily you can scale up with no disruption, with no downtime, almost instantaneously by a simple auto command, and continue to execute on that. So that was from the day one, and I think that's still a fantastic value for everybody who was working ever in restricted capacity environments, or even in generation one cloud systems, as we call them. Snowflake grown substantially even since the time I've joined, and definitely from the beginning. Just a couple of interesting data points. As of April 13, the average daily queries was around 3 billion queries a day across the whole cloud. And we definitely see customers running thousands and tens of terabytes, tens of trillions of records in tables. And as I'm quite involved in the data vault footprint on the Snowflake platform, we are hosting one of the largest commercial data vault deployments in the world, and also multi-petabyte beasts. It's powering a lot of business decisions. Now, I'll try to connect this to the data vault and what people are going through when they decide which methodology to use. And firstly, where this is starting from. Right now, organizations are realizing, okay, now I have a data platform, best in class, that could feed all of my data and never run out of compute, never run out of power. They naturally start to ask themselves, what is the best methodology that's going to allow me to future-proof my next decade, right? How do I scale? How do I roll out in this cloud journey on the best foot? And the answer is there is no one size fits all, because quite a few, of course, going to start with a green field, but for many, there is some sort of migration or revolution happening as well. So the truth is the journey is quite mixed. And that's why from Snowflake side, we are, in a good sense, data modeling agnostic. We definitely can see different patterns, different processes, schema on read, schema on write, integration. We see quite a lot of systems with Kimball style architecture migrated and lifted and shifted for the immediate benefits. We've seen third normal form, but we definitely see a significant increase in popularity of the data vault, again, from the perspective that it is probably the most thought through, the most future-proof, and the most agile methodology and architecture currently available on the market. When it comes to the implementation of a data vault, again, left to right, the slide is representing the different life cycle stages of the data, from acquisition all the way to your final consumers. The typical blueprint is that you have transient or permanent loading and staging area, and given the cost of storage is nowadays super cheap, more and more are leaning towards permanent, keeping the data in the original format as is, and then moving it through the raw business vault area, and then going into the information delivery. And again, I really like that Zoltan mentioned that no, you're not abandoning your favorite dimensional model or your unified star schema, if you like. It's still going to be your interface. It's still going to be something familiar to your business users, or what fits best for your scenario. But what matters is integration point. This structuring is going to be now done via raw and business vault, which on the physical side could be a set of schemas, set of databases. From our perspective, this is all semantics, what works better for your tooling, for your DevOps. And also, as you would see this dotted line, the business vault and information delivery would definitely see more and more being virtual first and then physicalized when necessary. The reason for that, Snowflake is quite powerful, even on the smallest size compute, extra small size of compute, as you would notice, that quite a lot of customers realize that they can persist data in the raw data vault, changing its shape, and then business data vault transformation and even turning it into your, let's say, facts and dimensions could be done virtually. And you definitely benefit from it during software development lifecycle, but also quite a few ask themselves, well, if that's a data point that's not going to be accessed by thousands of users of mine every day, why don't I benefit from the fact I can redeploy a view within a couple of seconds and deliver the new iteration or new version of my mart? And then having the elasticity that Snowflake provides, scaling it to what would fit my performance requirements. Again, if it's going to be something that everybody looks at in the morning, you may choose the material to materialize as objects, but you can go pretty far with virtual first. Which, by the way, this transition is, I think, something that you need to ask yourself whether you can do this switch between materialization options as a part of configuration rather than handcrafting a lot of code. Now, the other angle, as we spoke, or a benefit that Snowflake and Data Vault are bringing together, is that Data Vault is really designed from the append-only perspective, almost across the board, and it's really well aligned with cloud architecture. In particular, when it comes to those Lego-sized blocks, hubs, links, satellites, the fact that you are now in Data Vault 2.0 is using deterministic keys is allowing you to remove the parent-child dependency from a logical perspective, so you don't need to wait to process hubs before you process links or satellites. You can do everything in parallel. And with the features like multi-cluster warehouse set up on a Snowflake side, this means it's one configuration, one warehouse, if you like, on a day one, and you keep on throwing SQLs to process or jobs to process those objects, and Snowflake would take care about automatically scaling out and then scaling back down when the processing is finished. So you're paying only for what you use, but you try to process things as parallel as you can. There are many other aspects, but I just want to finish my slide by some of my findings, because again, I'm involved in the majority of the data vault conversation globally. And these are the things that I usually represent. And you would hear Ken Graziano talking about the same, the Lynch, Stancy, Meyerson. Now you have you pick the right data platform that allows you to focus on what matters. Again, data vault is not rocket science, but it's something that you need to grasp. So it's great that data platform question is already done, right? You have something not to worry about. Now, skills is an important part, right? Make sure that you have people who trained, who ideally certified, who knows how to leverage the community of the Data Vault Alliance and other meetup groups in the region. So, because it really matters when you have somebody to validate whether certain things should be modeled as a set of attributes on a satellite or separate links and hubs. Sometimes you just need to bounce those ideas with somebody. Quite a lot of vendors are offering coaching services, so I definitely see that being super popular as well. And of course, the automation part, as Zoltan mentioned, well, it's really cool to handcraft DDL, DML when you learn in Data Vault, but for the real production use cases, you want to benefit from the fact that Data Vault is template-based and you should be automating as much as you can. I hope I'm not too much over my time. Thank you for the opportunity, and over to you, Abby.
Thanks, Mitra. Great. So I was going to tell you a little bit about giffgaff's journey. So let's start off with who giffgaff are. If you're from the UK, I'm sure you've heard of us. If you're from wider abroad, probably not. We're a mobile virtual network operator. We've been operating in the UK since 2009. We've got over 3.9 members that we service. We've recently become B Corp certified, and as an environmentally conscious consumer myself, it really makes an important difference to me to feel like I'm working for a company that's trying to make a change. And it's very much in line with our fundamental culture. It's embedded pretty much into our working practices that we're about working with customers. In fact, giffgaff actually means mutual giving in Scots. which I only learned. I live in Scotland, so I only learned that the other day. It's true, it's on their website and everything. So a little bit about kind of where we started. So as I say, we were founded in 2009, and we were very much data driven from the start. But like many organizations, data grows, we get more data sets, the detail and granularity of your data grows, and therefore you have larger data sets to deal with. And we had hungry data scientists that were keen to get hold of all of that types of data. And we started to get to a point where our legacy systems were hitting their limits. And that's where we found Snowflake. So we, in fact, had a couple of really big new data sets that our legacy systems just weren't able to handle. So we looked at trying to find ways that we could manage that data. We did a POC, and within a couple of weeks, we had with Snowflake, those new data sets being ingested into our Snowflake platform. It took a bit longer, obviously, to productionize that, but the point was that we could get the data in and we could query it and start utilizing it. So we had an environment to host our data, but then we had to think about how we were going to model it, and we chose Data Vault. And just to talk you through the drivers for why we chose Data Vault. So the first one really was that our enterprise platform was changing, so we were moving from a monolith backend solution to microservices. And this means that our data feeds were going to change, that we were going to move from having large batch data feeds coming through daily to smaller, more frequent events. We didn't yet know what these were going to look like, but what we did know is that there was going to be more of them and we would need to support change. The other issue was that we were conscious of the legacy constraints, so we needed to make sure that our new solution was going to be scalable and more manageable, so less hidden business logic. And finally, there was a talk by Michael Stonebreaker at the Big Data London conference that really resonated with us. The talk was called Big Data Disruption and the 800-pound Gorilla in the Room. And what he was saying is that he felt that the big data platforms had solved the velocity and volume problems. And we kind of seen that with Snowflake, right? So we were able to get in our data. But what he reckoned was that the 800-pound gorilla in the corner was that the data scientists were still spending about 80% of their time cleansing their data, not doing the actual data science. And as I say, we had a keen data science team and we wanted them to be doing the cool stuff, not having to clean up the data. So we were looking for something that would help us with that. And that's why we chose Data Vault. So Zolly was talking earlier about the pillars of Data Vault. On the methodology side of things, that included repeatable patterns, an agile way of working, addressing our concerns about the evolving upstream data sets. Then the architecture has got a focus on scalability, and then the modeling emphasizes unifying those data sets around the key business entities, allowing flexible but clean access to new data sets. And I would just flick back over to Dimitro's slide. Our architecture now looks very similar to this, which is good news. It could have been embarrassing otherwise. So on the loading and staging area, we've got a persistent staging area. So that's basically is effectively our data lake. But because we've got it inside Snowflake, it is also got all of the governance controls over it. And then on the raw data vault side of things, we've got DBT managing our load from our persistent staging area into our data vault objects. We use the business data vault to apply softer business rules and also to map our data sets together using bridge and pivot tables. And finally, on the information delivery slice, we've got information marts, data marts, and also flattened out data sets. And that's a mixture of virtualized and materialized data. The platform is proving to be a great success. So data science now draw analytics out of previously inaccessible data sets. They've got the data hooked up to their own ML pipelines, which in turn feed data products which go out to the wider business. We've got all of our major data sets migrated, and we're in the process now of moving users and reporting solutions over to the new system. And we've seen loads of benefits. But I think the area that I really appreciate as a data engineer, having worked on lots of enterprise data platforms over the years, the pain of the bottlenecks in the solution is through the support and extensibility that Data Vault offers. So just dig into that a little bit. Because Data Vault has got standardized patterns, it means, as Dimitro was saying, you can have standardized codes around those pieces. So it's easier to support, it's robust, and it's simple to implement change. I can give you some examples here. So this is an example of a macro that we have in DBT, which will load a hub. We've got similar ones for loading all of the Data Vault objects. We've got unit tests that are embedded into our CI pipeline. So if we deploy any changes, then we've got the instant regression test, which means that we've got safe deployment for fast changes. And we've also got macros embedded directly into our data pipelines as well for doing things like data integrity. And then from a dev tooling perspective, we've also got code generators within our dev tools, and they will initialize components across the project. We've also got macros for unit testing and pre-prod testing, so using the Snowflake cloning feature to be able to get a copy of the prod data to test on. And all of this means that it's easy to onboard our new team members and avoid that single point of failure. So that increased bust factor. Not that I want any of my team members to get knocked over by bust, of course. And it's not just code, it's processes as well that can be standardized. So alongside having the reusable macros and components to implement, the data model itself decouples data sets. So we can introduce those new data sets without impacting the existing ones. I've got an example here. So in this here, we've got like a product hub and a set of satellites that sit around it. And one of those satellites might be a feed from a third party. And say we want to change our supplier, then being able to, there might be errors if we try to map up those two different data sets. They might not align easily together. But we can just simply add the data in by creating a completely separate satellite. And then we resolve those differences in the business vault area, and it becomes hidden to the end user. Of course, there's been some challenges around on the journey. There's been a number of design decisions we've had to make. For example, we had to make sure that we're designing into processes within our system to ensure we've got regulatory compliance. I mentioned earlier that we've got an event-based architecture, so we need to consider the order those events are going to arrive in. We need to take trade-offs in terms of having fresh data versus performance and consistency. And then there's softer things around the people engagement. So having access to new shiny data is an easy sell, but trying to migrate people over from an old system, albeit with flaws, onto a new system is a harder sell. But I think the one that I thought would be interesting to drill down on is really about the gap between the raw vault and the presentation layer. I feel like it's less talked about because the patterns are less prescriptive. The majority of usage is going to come through that information layer, right? Because that's where you've optimized for querying, it's where it includes all the soft business logic. But eking out some of those requirements can take time. It might take iteration. We might need to have other people involved to be able to understand how they're actually going to be using the data. But we were getting the benefit out of getting data quickly into the raw vault, and we wanted to push that process further down the chain, even if it's just to be able to get early access to those data, to do prototypes, to iterate through kind of exactly what the reporting requirements were. And just to help understand why we don't like to give people access directly to the raw vault, we take the scenario that we had before. You've got, in this scenario here, we've got several different satellites hanging off the same product hub. We talked about having third-party data, so that's likely that they're not going to have the same business keys that you have internally, so we might need to have a same as link to join those keys up together. And then we've got different timelines in each of those satellites. And in our case, we had an audit timeline as well as a business effectivity timeline. So you've got to resolve all of those different timelines before you join those data sets up. And not only is that a bit of a pain to do to write out the SQL every time, it's also error prone. So what we did is we employed one of the business vault objects called an incremental pit table, and that basically is consolidating the timelines across all the satellites. And then for each of the satellites, it provides a link to a unique record within each of those satellites that's relevant for that validity date range. Now, no, this is an incremental pit table. You more often get spoken about snapshot pit tables. For us, whilst we do use snapshot pit tables, but a lot of the times we have data where we have intraday changes. So having snapshots at that granularity would have meant exploding out the data. And so this was a more effective way for us to get access to the data changes. It's a thin table, so we can materialize it, and it's relatively simple and performant to either incrementally update, and if you fully refresh it, it will fully refresh in a consistent way. And because this is a standard process, again, similar to the things that we're doing in the raw vault, a generic macro can be made and to link up a hub with any number of satellites. So that created our safe links to all of our different satellites from a single hub. But we also might want to avoid all of that tedious SQL of having to join it up if we've got lots of satellites. So again, we create a view over the top of it, repeatable pattern. So again, another generic macro. But we can also insert into there our conformed soft business logic alongside to do things like resolve kind of version attributes. And because it's virtualized, we can include all of the columns in that. So it can provide a flattened out view across all of the data. The last thing I wanted to show, it's a little bit geeky, but it's a really cool feature, I think, inside Snowflake. So one of the problems with creating a view across a lot of different tables is that you might not necessarily need to access all of that data. You might only need to access a thin slice of it. And if you do requested, so the example I've got here, we've got just data coming from one of those satellites. And you'll see if you looked in the query plan that what Snowflake's going to do behind the scenes is it's going to join up to all of those different satellites before it returns the data that you want. But now if you add on primary and foreign keys onto those tables, whilst they're not going to do anything, Snowflake doesn't enforce any integrity. What it will do is it gives Snowflake a hint to know that it doesn't need to do the join to all of those tables. And then what you get is a query plan like this, where you can see it's just joining to that one satellite. So a little bit geeky, but I think it makes a difference, particularly around the points that Dimitri was talking about, virtualizing some of the data, because these types of techniques can help you do some of that virtualization and still get optimal performance. Okay, so takeaways then. For us, Data Vault has really delivered on its promises. We're able to extend easily. We've got robust pipelines. It's easy to support. And a lot of this success, I think, is because we spent a good amount of time upfront identifying those key business entities and making sure that we had the foundation to build the rest of the solution on. Identifying the patterns and standardizing the code is definitely rewarded. It takes time upfront to get that work done, but it means that you're going to be more efficient in the future, both from a support as well as extensibility point of view. And finally, there are design decisions to be made. We did some of that by iterating and refining our codes, but we also called on the experience of our partners like Infinite Lambda and Snowflake to challenge our assumptions. I think Dimitri mentioned that sometimes just being able to talk through some of your scenarios to make sure that you're doing it the correct way, and also getting experiences shared from other customers, because these guys have had experience in seeing other people implement it and getting ideas for the best way to implement for you is definitely helpful. And that was it for me. Thank you very much.
Thank you so much, Sherry. It was really, really nice. It was good to see you all these real-life experiences. When we talk about how this should be done, this is really good to see at the end. Someone did it and we did it together and have actually proved itself that following the standard and practices really give the value. And I have a couple of questions in the questions section. Conscious of the time, I will just go and pick one of these. I will start with one question about from Harun about what are the key benefits of having Data Vault compared to conventional Kimball data warehouse. So I would mention three pitfalls here. The first is one of the most important for me is when you not start from the business approach with Data Vault, when you try to do a technical approach, not understanding the business or the data, it's going to end up in the source data vault, we call it. This is an anti-pattern here. And that in order to avoid doing this, actually, we have to talk to the business, and we have to start from a top-down approach. We build the glossaries. If you don't understand what we have, we build conceptual models, and so on and so on. The second would be, what I mentioned, not utilizing repeatable patterns, not generating the code and try to do it manually. That's also a big mistake, because one of the advantages of data vault actually that it has very well-defined, repeatable, simple patterns. So we should generate the code based on metadata and in these templates. If we do this, or the result will be faster, but also better quality. If you have to change something or repeat it again, you can regenerate everything from scratch in a matter of minutes. The third one is not following standards. If you try to invent your own ways, you might succeed if you're very, very smart, but most likely we will make some mistakes, and it's going to, you have to pay for that one later, big time. And that's from me. I don't know if anyone, maybe or Mitro, would like to add anything to the question.
I've just, if you don't mind, would quickly add on generating code, right? Because there is no one-size-fits-all framework. So I've been mentioned they're using dbt, and this is what works really well for their talent, their audience, their skills. There are like a full spectrum of products available in the market, right? From build your own, like I have customers who build their own automation metadata-driven frameworks. But you need to be conscious that this is engineering. This would require time to align it with the methodology, align it with what code it generates. So you kind of build the product so you can then build another product. You then have a good selection of open source tools, and you have commercial on the other side of the spectrum, right? My recommendation, there is no one winner. I usually suggest have a look on a few, and from that understand which would fit best. But definitely agree with Zoltan, do not try to handcraft everything. You're undervaluing the investment in data vault.
That's very good advice. Let's take another one. This one, I believe, is for Abby. What would you approach differently if you had to implement the solution again, knowing what you don't?
Oh, that's a good one, isn't it? I think like thinking up front about some of the things that are going to impact you. So things like the data coming in. So how are you going to handle things like your event timelines changing, and then from the business vault perspective is trying to. I think we reviewed what we wanted to do in the business vault a few different times, because the raw vault is very kind of clear what it is that you need to put in there, and the dimensional modeling piece is kind of a well-established piece, and try to work out kind of what the things are that you can put in that middle piece. I think we might have spent a little bit more time looking at those processes up front. Yeah.
Yeah, that's a good one. Thank you. We still have a couple of minutes, so let's pick another question from here, from David. What are the most common pitfalls when implementing a data vault project? I think it's kind of similar. And for most, pitfalls. I think we explained it before in the previous question about not starting from the business, utilizing repeatable patterns. So
if I might just add to your point that not deviating from data vault, because sometimes what I see deviating data vault is by just not knowing it thoroughly, and this is where unfortunately data vault is one of those technologies which is hard to implement just by reading 2 books, right? Books are great, But from my experience, I went through the training, through the official training and certification process. It's not like they're sharing you absolutely hidden things, but they definitely emphasize enough on thought through patterns and templates for things which you may kind of undervalue just by going through the book content. So same as links, how to be built and where to build point in time tables, bridge tables. In my experience, it clicked only when I was in the training.
Okay, thanks.
I think there's something as well around kind of making sure, the points that you were saying earlier, Zoltan, around working from the business perspective as opposed to just from the source perspective. Because if you model your data just based on your source, then you'll miss kind of where it is that you need to deliver your analysis on.
Okay, so I think it's okay as well. Maybe just one more here is, again, what is the ideal team topology for delivery of a project like this? Concept design and implementation. That's an interesting one. I think we discussed, again, I just mentioned my part from the business approach from the business. So someone who actually understands the business, someone who actually can do the modeling, and also who can do the implementation as well. So if you have a tool actually, and you can generate everything, you don't have to code too much. Implementation will be faster and easier. But I would think about traditional thinking. Business analysts and data modelers definitely needs to be there with someone do the implementation. Other opinion on this?
No, I think that sounds good.
You and we have one last one, probably. That's for Dmitro.
I think it's actually for Abby, right? I'm biased in this one.
That's quite interesting, actually. So we don't use dynamic tables at the moment. I'm thinking that probably the place that we're most likely to be able to utilize those is, I talked earlier about having some of our PIT tables that join our data sets together, but then materializing that through into our data mart schemas. We can probably do that quite nicely from those consolidated views directly into our tables by just creating a dynamic table on top of those. So that's where my mind currently is in terms of where I think that would be the first place that I'd like to see dynamic tables being used, but we're not using them yet.
Thank you, so conscious of the time, yet out of time, I would like to thank you for all of you to attend to this webinar. I hope that you found this presentation useful and enjoyed this. Thank you, Abby. Thank you, Dmitro, as well. And we are going to send you the recording as promised with the questions and the answer. So thank you and see you next time. Have a fantastic day. Bye-bye.
Thank you. Bye.
Thanks, guys.